Before watching the video, don't forget to subscribe to our channel by clicking the subscribe button below and clicking the bell icon to be notified whenever we publish a new video.
Collisions happen when two or more objects come into contact with each other and a transfer of momentum and kinetic energy occurs. Collisions occur every time you hit a baseball, bounce a basketball, or play pool. When objects collide in the absence of external forces, they form a system in which the net momentum of both objects before the collision equals the net momentum of both objects after the collision. There are two types of collisions: elastic collisions and inelastic collisions. An elastic collision is defined as one in which no kinetic energy is lost, no damage is done to the objects involved, and there is no generation of heat. In the real world, no collision is perfectly elastic because so many other forces come into play, like friction, air resistance, and gravity. However, the game of pool offers a fairly good elastic representation. Pool tables and billiard balls are designed to reduce the effects of friction, resulting in close to ideal elastic collisions. When the cue ball hits the resting 8 ball, it sets the 8 ball in motion. Having transferred all of its momentum and kinetic energy, the cue ball comes to a rest. The net momentum of the cue ball before the collision equals the net momentum of the 8 ball after the collision. Momentum and kinetic energy are transferred and conserved. If the 8 ball is already in motion when a similarly moving cue ball collides with it, then the 8 ball will gain some of the initial cue ball's momentum, and the net momentum before and after the collision will be conserved. If the 8 ball and the cue ball are traveling at the same speed and collide head-on, then they will bounce off of each other with the same momentum, but in opposite directions. Their momentum and kinetic energy are transferred and conserved. The second type of collision is an inelastic collision. In an inelastic collision, momentum is still conserved, but kinetic energy is lost in the system, resulting in the creation of heat and damage done to the colliding bodies. Bodies that are involved in an inelastic collision end up entangled with each other or stuck together. A clear example of an inelastic collision is a car crash. In order to understand the conservation of momentum in this example, we'll imagine a car crash taking place in a world where road friction and air resistance have no bearing on the system. Let's take two cars, A and B, with equal mass. Car B is parked when car A plows into it head-on at a velocity of 10 meters per second. Kinetic energy is immediately lost as the cars become mangled and stuck together. Some energy is converted into heat. Momentum after the accident, however, is conserved. With no road resistance, the doubly massive car wreck will continue moving in the same initial direction as car A, but at half the speed. The after-collision momentum is easily calculated using the conservation of momentum equation, where the mass of car A times its speed of 10 meters per second before the collision is equal to the mass of car A plus the mass of car B times the final velocity after the collision. Rearranging the equation to solve for the velocity after the collision gives 5 meters per second.
Thanks for watching. If you like the video, give it a thumbs up and share it with your friends. For more tutorial and tips, subscribe the channel.